Hi, I'm Mr. Bay. In this video, I'm going to discuss with you another experiment regarding the KSSM Physics Paper 3. The experiment I'm going to discuss with you is one of the experiments related to Form 5 syllabus, Chapter 2, 2.5 Archimedes Principle. So the aim of the experiment is to determine the relationship between mass of an object with volume of water displaced. Before we go for the detail of the experiment today, so let me tell you the type of the experiment you are going to see in the question of paper 3. So if let's say you have watching my previous video regarding paper 3, you should know already the type of the experiment can be classified to two types. So where the first type they will be known as a hypothesis experiment. So in this experiment, they will be involve at least 5 manipulated variable and responding variable, and the candidate are requested to plot the graph. The another type of the experiment is known as non-hypothesis experiment, and mostly will be no involve any manipulated variable and responding variable. And the question will be normally not ask students to plot the graph. So if let's say you want to know about the detail of the type of experiment, you may watch my previous video where you can get through my channel. And in this video, I'm going to discuss the experiment regarding the hypothesis type of experiment. Besides that, you'll be see the question in paper 3 can be classified to two types, where the first they will be known as tugasan AMALI membantu, where the procedure and diagram is provided, while another type they will be known as tugasan AMALI tidak bantu, and the procedure and diagram will be not provided. So the candidate must be understand the apparatus and then plan an experiment related to the aim request by the question. And in this video, I'm going to share with you the type of question in tugasan AMALI tidak bantu. Let us go through the question now. Okay, so this will be the instruction. Basically, you will see at the question. So the question will be like this. You are requested to check the list of apparatus and material. Read the question and plan the experiment in the first 5 minutes. So tick in the box provided to check the apparatus and material prepared. Basically, the duration for candidate to answer paper 3 will be about 45 minutes. And the first 5 minutes, actually, student will be need to check the apparatus. Is it all of the apparatus or material is functioning well and sufficient according to the list? Okay, let's say, for example, in this question, so the students will be give 50 ml of measuring splitter, 20 ml of water in beaker. Will be this, and another one, there will be numbers of bubbles. It will be 5 with a mass of 5, with a mass of 4 grams. So let's say all the material is sufficient and functioning well, you can just proceed your experiment. Okay, so this will be the question where you need to identify the MV and RV so that you can start to plan or do your experiment. Okay, so the question will be like this. So diagram 1.1 shows a boy and his father sitting on 2 identical beach balls, so A and B respectively. So you can just look at this figure. So the boy is sit on beach ball A, and then the father will be sit on the beach ball B. So it was found that the larger the mass of the father, you can see here, the larger mass is father, then the crater of volume of water displaced. You can see here, the father have a crater mass and you can see the water displace will be more. Okay, so actually the question already indirectly tell you the MV and RV where you need to identify so that you can conduct the experiment and get the data you need. Okay, so the question number 1, they will be based on the information and observation, state one suitable inference. Okay, so this is a normal question you are going to see in paper 3. So how we are going to answer this question, inference. Okay, so here this will be the answering technique tips for answering the inference. Okay, so you can see here. Okay, so you can using this method to write your answer for inference question. So the RV depends on MV, so that you need to identify what is your responding variable and manipulator variable in this experiment. Okay, so here, through the question just now we go through together, so you should know already the mass of father or the mass of the object should be the MV manipulator variable for this experiment. So where the boy showing the lower mass while the father showing the higher mass. Then the next here, volume of water is displaced, there will be the RV. So where the volume will be the volume of water displaced will be the responding variable we are going to measure in this experiment. Okay, so the sentence will be the RV here. The volume of water displaced depends on the mass of the object. So you say you follow the format I showing you here. Okay, so this will be the correct answer for you. So volume of water displaced, RV, depends on the mass of an object. So where will be the MV for this experiment? Okay, so the next question here will be state one suitable hypothesis. Okay, so hypothesis will be more common for students compared to inference. So however, the method will be this. Okay, so when NV increases or decreases, your RV will be increases or decreases. Okay, so here just now we mentioned already, for our NV, it will be water, there will be mass of the object. Okay, so here, if the mass of the object increase, for example, using father as an example, so you can see the volume of water displaced will be also increased. So here we very clear that our MV increase, our RV will be increased also. Okay, so here you can write as when the mass of an object increases, MV increase. Okay, so the volume of water displaced will be also increased. You can just referring to the diagram 1.1 here. Okay, so this will be the first 2 marks. Okay, so the total marks for the paper 3, there will be 15 marks. Okay, so here this will be the question where just now I mentioned to you, the procedure and diagram is not provided, and we know as this are question as tugasan analytical part 2. So you must able to relate the MV and RV just now we identified with the apparatus we want to is given. Okay, so the apparatus given, so that you can get the phi MV and RV, and then you can plot the graph. Okay, so here this will be the question. Okay, so with the use of apparatus given, plan an experiment to investigate the hypothesis stated in A2. Your description should be include arrangement of apparatus. So that means you need to draw the diagram for the arrangement of the apparatus. Okay, then second, there will be the procedure of the experiment, which include one method controlling and the manipulated variable together with one method of measuring responding variable. So that means you need to give controlling variable, manipulated variable, and responding variable in your procedure. So total you will get 4 marks. So here they will be very clear that the first mark will be given for your arrangement of apparatus. So you have to draw the diagram. Then another 3 marks they will be for your procedure. Okay, so here this will be the hypothesis where just now we explained already. This is the answer where we get from A to request by the question here. B. Okay, so when volume of mass increases, the volume of water displaced increases. So here the MV will be the mass, RV will be the RV will be the volume of water displaced. Okay, so here how we can write correct procedure so that you can get full marks now. So here the first mark there will be the correct diagram with label and symbol used. So you have to label your diagram, then you can get first mark. So is what requested by the question here. Then the second mark, second, third, and fourth mark, they will be procedure. So the first 2 marks, you need to give your first MV. Or just now, if let's say you still remember the apparatus given here, we have 5 pieces of the marble. Okay, 5 pieces of marbles where the marbles will be have equal mass, which is 4 grams. So that means here our RV will be the first marbles, which is 4 grams. Or you see the first MV here will be 1 marbles, which is 4.0 grams. And then the RV here, there will be corresponding variable. So where we are going to measure the volume of the water displaced, where we're using the measuring cylinder. Okay, so where given by the question. So this will be the water of volume of water displaced by using the measuring cylinder. Okay, then the fourth mark here, you have to repeat your step 2 and 3 with another 4 MV and RV so that you can get minimum 5 MV and RV for plotting the graph. Okay, so let us go through the procedure together. Okay, so here this will be the way how we write the answer. So first mark, just how we explain, we have to draw correct diagram with label. It will be like this. Okay, so here by using the apparatus and material given. Okay, so this is the first sentence you have to write. So the apparatus is set up as shown in diagram 1.2. So you can see here 1.2 here, the first diagram 1.2a, there will be measuring cylinder with initial volume. Okay, so here the question not give you the information regarding the volume you need to use. Okay, so you have to identify yourself. Okay, so here I suggest you can using 30 ml. So the water volume provided will be about 200 ml. Okay, so you can using 30 ml for this experiment. Okay, then after that you have to put in or place the marbles to the measuring cylinder. So we expected the volume of water or water level will be rise, like diagram 1.2b. Okay, so this will be the first mark. So where request by the question. Okay, then second, so here this will be our control variable. Just now I explained to you already. So where the water level initial we can set as 30 ml, where showing by diagram 1.2. So here initial water we using symbol V0 with 30 ml or water is poured into the measuring cylinder as shown in diagram 1.2a. Okay, then second and third mark, just now I explained to you already where you need to give your first MV and RV. So the first MV here, there will be the first marbles with 4.0 grams. Okay, so the sentence will be like this. Then a marbles with mass of 4.0 grams is slowly immersed into the measuring cylinder. So this will be your second mark. This will be first mark with diagram. This will be the second mark. Okay, then the third mark will be record RV. So where here will be the volume of water displaced or the water level showing in 1.2b. Okay, so here volume of water displaced. So the sentence for RV1 will be like this. The reading of water level in the measuring cylinder, so I put as VI, is recorded. So you can get your third mark already. Then the next, you have to repeat your MV and RV. So here the sentence will be, step 3 and 4 is rated with 2, 3, 4, and 5 marbles. Okay, so from here, you should know when go to second piece of marbles, the total mass will come to 8.0 gram. 3 marbles will be plus 4, 12. Then 4 times 4, there will be 16. And then 5 marbles, there will be total about 20.0 gram mass. Okay, so for each data here, you need to recording the volume displaced or the water level height. So before we go for more detail of the question you are going to discuss with me here, so let us see the stimulation for this experiment. So welcome back to our question discussion again. So I think that you should very clear already how to conduct this experiment through the stimulation I showed you just now. So for question C here, they will be related to tabulation. Okay, so tabulate the data for all value of M, Vi, and V in the space below. So here you need to identify what is the symbol represented as M, Vi, and V. Okay, so here the M represents the mass of the object. There will be the mass of the 1 marbles, 2 marbles, and others. So the Vi here will be the water level for a certain numbers of marbles. For example, when we place 1 marbles into the measuring cylinder, so the water level shows by the case will be the V1. Okay, then the V here, this will be the volume of water displaced. Okay, so where we're using the Vi minus the V0 so that we can get the volume of water displaced already. So where will be equivalent to 30 ml. Okay, so here before we go for the detail for answering technique of tabulation, so now here I want to show you how to give the correct sensitivity of the instrument used here. Okay, so here in this experiment, we will be using the measuring cylinder to get our water level or reading for certain numbers of marbles. Okay, so here, if you look at the measuring cylinder, the smallest division, okay, so the smallest division here, there will be 1 ml or 1 cm cube here. So here, there will be no any decimal place needed actually. So every segment will be showing whole number. Okay, however, if let's say the water level is just between 2 segments, so you can actually give 1 decimal place. Okay, so here I'm going to show you the example. So you can see here, no decimal place or 1 decimal place you can use for your data here. So for 1 decimal place, the numbers will be 0 or 5 only. Other than that, they will be not accepted. Okay, so for example, okay, so here this is a reading. This is the first reading where I get in my experiment. So you can see this picture where I place 1 marbles inside the cylinder. So this will be the reading. So you can see here, the meniscus of the water is actually at the data where between 32 and 33. Here will be 32, here will be 33. Okay, so here we can give the value as 32.5. Okay, although you can see this meniscus is more close to 32, you cannot give any value where you think that it is close to 32, where you can give 32.2, this will be wrong already. So we will be only accept 0 or 5, where I mentioned just now. So in this case, okay, so you can actually give 1 decimal place where you can give 32 or 33. Okay, you can follow the below segment, which is 32, or you can using 33. This is option. Option 1, where no decimal place needed. Okay, if let's say here you choose to give 1 decimal place, so here we just not experienced it should be 32.5, right? So if let's say you want to give 1 decimal place, here you can give 32.0 or 33.0. So here I select 32.5 because most of my reading is actually in between of segment. So here I choose to give 1 decimal place. Actually, as mentioned, you can actually using 32 or 33 without any decimal place. Okay, so another data here I want to show you. So here, this will be the last data I get where I place 5 pieces of the marbles inside the cylinder. So I get the reading here. You can see is exactly, the water level here is exactly 41. So again, you can choose no decimal place, which is 41, or 41.0. Okay, so here, because I already select the value with 1 decimal place, so I need to give consistency on the decimal places for the tabulation. So here I must choose 41.0. So we cannot give data with sometime no decimal place, another time you choose 1 decimal place. So this considered non-consistent already. Okay, so now let us go to the tabulation question here. Okay, so just now we have already go through the symbol for tabulation. So where M will be object mass, VI will be water level, reading for certain numbers of marbles, and then the V here, there will be the water or volume of water displaced. Okay, so here the M will be with symbol of G, gram. VI and V, they will be with ml or cm cube. Okay, so here the answering technique for tabulation, you need to fulfill 6 ticks here. Okay, so the first tick, you need to give the quantity physics. So where showing with the symbol already. So here there will be M, which is represent a symbol for the mass. VI and V. This will be the first tick you need to take note for the format of tabulation. Okay, so second, you need to give the unit. So here we have the unit of mass, which is gram. Then the volume here will be ml or cm cube actually. Okay, then the third and fourth tick, there will be primary reading with the decimal place based on the sensitivity of apparatus plus consistency. So just now I already teach you how to select the correct sensitivity of apparatus. And here we're using the measuring cylinder. So measuring cylinder, so where will be, okay, so the first, here will be the mass for 1 piece of marbles, and the decimal place is actually stated in the question already. So when give as 4.0, so here we just follow the decimal place given by the question. Okay, so here started with the value of 4.0 gram. So with 2 pieces of the marbles, there will be 4 plus 4, you get 8.0, and then will be others also. So you can see here, all must be have consistency of the decimal place, where will be 1 for the mass here. Okay, and then the V1, be using the measurement cylinder. As mentioned, you are optional to give 1 decimal place or no decimal place needed. But for the 1 decimal place here, the numbers will be 0 and 5 only. So as mentioned just now, so when my first reading here will be 32.5, then my others data will be 34.2 for 2 marbles, 36.5 for 3, and also others lah. So you can see here, although my value for the last measurement I get 41, so I still give 0.0 because I need to have the consistency of the decimal place here so that I can get my mark number 3 and number 4 here. So this is so-called the sensitivity of apparatus and consistency. Okay, so the last 2 tick here, there will be the secondary reading with consistent decimal place. Okay, so here, just now we explained already, the formula for V or volume over the place, there will be Vi minus V0. Okay, so here, okay, so for mark number 5 and number 6, the consistency here referring to decimal point needed for your secondary reading. So when go through the calculation, for example here, minus, so this data we consider as secondary reading. And you can give 1, 2, 3, or no decimal place also possible for this experiment, because just as I mentioned to you. So this will be actually following the measuring cylinder sensitivity. Okay, but here I select 1 already. So my V here, there will be 32.5 minus 30, I get 2.5. Then for second value of V here, there will be 34.5 minus 30, so I get 4.5, and others. So you can see all value here showing consistency of the decimal place, where will be 1 here. Okay, so I think this will be very clear that if you get 6 tick here, you will get full marks for the tabulation. Okay, so the next question here, D. They will be related to the plotting the graph. Okay, so here the marks is 3 marks. So how you can get full marks? Here you need to fulfill 7 tick here. 7 tick, 6 criteria here. Okay, so here the graph going to plot here will be N against V. Okay, N against V. So here normally students will be thinking that the axis Y will be referring to the corresponding variable, where will be V. Then the axis X here, there will be M. This normally we see for the majority of experiment. So however, here the question asks you about M against V is still logic. Okay, it's actually not compulsory mention that your y-axis must be RV, your x-axis will be MV. So they can be others. So where you actually learn through the experiment, where you learn at chapter 1, the force and extension of spring. So you can see sometimes the graph will be M over X, sometimes it will be S over M. So the gradients actually bring the reverse meanings. Okay, so this will be same with the graph where M against V and V against M. Okay, so this is what we are going to highlight at the end of the discussion today. Okay, so before we do the comparison, now I want to give you the tips how to get the full marks for plotting the graph. Okay, so here this is the data needed for plotting the graph here. So where will be M against V? So the M here, just now we also go through already. This is a match for 1 marbles, 2, 3, 4, and 5. And then the V here, this will be the displacement volume, where we using Vi minus V0. So here, this will be the set of data we are going to plot. Okay, so for the answering technique for plotting the graph, just like I mentioned to you, we will be highlighted for 7 tick and 6 criteria. So the first will be quantity physics for both axes. So will be X and Y. Okay, so here you must give symbol M for Y axis and then V for the X axis. This will be the first tick or first criteria also. Okay, so the second, we need to give the unit for the axis. So you can see here, the volume will be VQ, or ml. Okay, then for the mass, will be gram. This will be the second criteria. Okay, then the third, there will be uniform scale. Okay, so here you need to give both uniform scale, where including the minimum and the maximum value in the graph. Okay, so here, give the correct scale with multiple of 1, 2, 5, and 10. Okay, so we must be including the maximum and minimum value. Okay, so must start with 0. Okay, so here, some of the teachers actually advise that the starting point is not always with 0. However, I still advise, if possible, we make it at 0, so that when you plot the graph where passing through origin, we can confidently mention that the x and y relationship here, they will be direct proportional. Okay, so here let's continue. Okay, so here, the first reading here, there will be 4.0 and 2.5. Then the last here, the maximum value here will be 20.0 together with 11.0. So your scale must be including the minimum and the maximum value. Okay, so here this will be the advanced scale I'm given here. Okay, so here the x-axis maximum value 11 is actually included. So where I give up to 12 already. Okay, then for the y-axis, the maximum value is 20.0, which is also the maximum value for the max here with 5 bubbles. Okay, so the first point will be 4.0 and 2.5. Okay, so here, if we go through the smaller division here, 10 small box with 2. So they'll be showing that the smallest box here, they'll be represent 0.2. And then for y-axis and x-axis, actually, they'll be also the same. So here, 2.0. One small box here will be divide 10. So equivalent to 0.2. Okay, so here can help you to get the more accurate point. For example, so 4 will be mass, there will be y-axis. 4 divide 0.2, so you'll get about 20, right? So that means that the value here will be 4. Okay, so before we go for plotting the graph, so here the selection of the scale will help us to get the correct size of graph, where actually there needs to have about greater than 4 times 5. So the 4 here, this is one box. So here request minimum 5 times 4 or 4 times 5. So that means it will be half of the graph actually. So the biggest of the graph you draw, they will be more accurate, the data you get. Okay, so here, the next here will be the criteria number 5. Plot all points correctly. So here, you'll be get another 2 ticks if I say you plot correctly. Okay, so the first, they will be started with V 2.5. And then Y, there will be 4.0. So this will be our first point. Second, there will be 4.5. Together with the 8. Okay, so be around here. And then also others point. Okay, so if you're able to plot all the points correctly, you can get 2 ticks for this criteria here. Okay, so this will be the criteria number 5. Plot point correctly. Okay, then the last here, you need to give the baseline. Okay, so draw baseline. Here we have 2 criteria. Here first, the numbers of points different above and below the line must be less than 1. And then the distance of the point to the line must be less than 0.5. Okay, so here, what means by numbers of points different above and below the line. So you can see my graph here. I have 3. Okay, so last will be baseline. So I have 3 points. So where circle with red 1, they will be above the line. We have 2. So below the line, I circle with blue color. We have only 1. 2 minus 1, you get 1. Where actually is fulfill the criteria of draw the best line here. Okay, so this will be the 6 criteria and 7 tick. You need to make sure you get this. Then you can get full marks or 3 marks here. Okay, so now you should know the way how you photograph already. Okay, so now we go for the analysis question. So the first question here, there will be calculate the gradients with symbol K, the graph M against V. So this is the graph where we got just now, M against V. So the question asks you to determine the gradients. Okay, so 2 marks. So firstly, you have to select big enough triangle in the graph. So where will be this? So you should draw the line and show a triangle in the graph paper so that the marker know which is the point to select. Okay, so I select first point 0, 0 with the last point here. Okay, so here this will be the value y1 minus y2 over s1 minus s2. So where will be 20.0 divide 11. So I will get 1.81 gram per cm cube. Okay, so you can just follow. Okay, so here should be gram, and then here should be cm cube. Okay, so here and now you get the symbol with gram per cm cube. Okay, so here the question asks about use your graph to determine the density of the marbles in gram per cm cube. Okay, so here, how we can get the density? So do you notice that the symbol, the unit you get at the gradients is actually the density, where mass over volume. Okay, and then the density here is actually the density of marbles. Okay, so you can see here, K will be N, will be here, and divide V. So it's actually equivalent to the density of object. So here we are very sure that the value of gradients in the graph is actually represent the density of the marbles. So the value for density will be 1.81 gram per cm cube. So this is quite logic. Seeing the marbles will be seen into the water, where the water density is only 1 gram per cm cube. Okay, so this is actually the 15 marks of question I designed for this experiment. Okay, so actually there are more related questions for this experiment. So let us go through a few more questions so that you can get more idea to answer the paper 3. Okay, so here the first extra question here is a question regarding the precaution. So where is very common, where you can see in the paper 3. Okay, so here, step 1 precaution that should be taken to improve the result of this experiment. Okay, so for answering technique for precaution, you need to give the format of method plus reason. Okay, so what means by the method plus reason here? Okay, so the reference answer here will be like this. The position of eyes is perpendicular to the scale reading to avoid variance error. So this is one of the suitable precaution. So where is the method? So the method will be here. Eyes must be perpendicular to the scale reading. This will be method. Why you do like this? Because you want to avoid variance error. This will be the reason. So make sure that you give method plus reason for your precaution. Okay, so here this will be the second extra question. So where is related to the variable? Okay, so the first will be the manipulated variable. So just now we explained it. This will be related to the mass of the marbles. Okay, so we can give mass of marbles or you can just give mass of an object. Both is accepted. Okay, then the responding variable here, they will be also mentioned already. This will be water, volume of water displaced. Okay, so these two wherever you correctly answer it, it will be 1 marks. And then the last here, constant variable. The constant variable here, they will be the marble size, density of liquid, or just now we give the initial water volume also can be accepted. Okay, so here, you must make sure that the variable you give is measurable. You cannot give the answer like type of liquid or type of marbles, where it's not able to measure. Okay, so this is answering technique where you need to take note in this question. Okay, so next question here, this will be the relationship between the M and B. So you can see the question will be like this. Based on the graph at D, state the relationship between M and B. Okay, so here, the graph M against B, you can see the straight line is passing through origin. So it should be the type of question where Y is direct proportional to X. So the answer here should be M direct proportional to V. If let's say your graph, you get the straight line not passing through origin, but it's passed through the Y-intercept. So the relationship here should be Y increases linearly with X. Okay, however, you must think logically whether when your V0, your M will be got a certain value. Is it possible? So in this case, this is impossible because without place any object with certain mass into the measuring cylinder with water, so the volume will be not displaced. So here you should get passing through origin. Okay, then the next question number 4 is a prediction question here. So predict the changes in gradients of graph if the water in the measuring cylinder is changed with olive oil. Okay, so we know already the olive oil, the density is lower than water. You see the gradients of the changes. So here, the gradient should be not affected because just now we also go through already the discussion where the gradients of the graph is actually showing the, okay, represent the density of the object. Where will be the density of the marbles? Therefore, the answer here should be no changes, although we changed already the density of the liquid here. Okay, so here before we end for the discussion today, so let us compare two types of graph. Where will be the graph M against V, where we discussed through this video clip. Okay, so another graph V against M, actually you may go through with my another Archimedes principle experiment where I did already last year. Okay, so you can see actually there are two types of graph possible to tell us the opposite meanings actually. Okay, so just now we go through already the discussion for the graph M against V. So the gradients is actually represent the density of the object. So where you can go through with my video clip today. Okay, so another experiment where I discussed about the graph V against M, where I did already last year. Okay, so the video clip you can actually watch again so that you will be more clear about the difference between the graph of V against M and M against V. Okay, so the link of the video clip you may get at the corner. I will be on later on. Okay, so here the graph actually represents V against M. So this is actually reverse of the density, where will be 1 over density. So this is a difference between these two types of graph. Okay, you let's say the question now asking you if the denser object replace marbles. So what is the gradient of the affected? You should get the gradient increases. As the gradient of the graph represent the density of the object. When we're using greater density of the object, it should have a greater gradients for the graph M against V. So the graph we expected will be above the blue line here, where showing by the red line. So on the other hand, if we using the graph V against N, so where the gradient represent 1 over density. So the denser object replaced with marbles, where the gradient will be actually showing smaller. So where will be the red line here? Okay, so this the discussion regarding these two type of graph where related to the subtopic of Archimedes principle. Okay, so I hope that the discussion today will be let you more clear about this experiment related to Archimedes principle. So if I say you think that this video clip is benefit for you, please share to more of your friends so that more students will be able to gain the benefit from my video. So please remember, share, like, and subscribe my channel. So that's all for today. Bye bye.